Here we go. Vectors and parametric equations of aligning are. Today is March the 30th, 2017. Okay, so today in this unit, we're dealing with the equations of lines in 2D and 3D. That's what this unit is, okay? So we'll be getting away from Cartesians and all that stuff. We'll be going to actually back to y equals mx plus b and things like that, okay? Except for in 3 dimensions. I'll be getting to. I'm going to start in 2 dimensions with the new forms for these, and then move on to the 3rd dimension by the end of today's lesson. All right, so to do this, to find these, okay, back from grade 9 and our 2 warm-ups. Okay, stay with me here, Chris, please. Back from grade 9, if I wanted to find the equation of a line in grade 9, what would I have to be given? One of 2 things.
2 points.
2 points. And what's the other thing you could be given other than 2 points? Some other than Derek. Sorry, Derek, I appreciate your volunteering. What else? It begins with an S.
Slope.
Slope and?
It's another S word?
No, slope and anything. What's the other thing you need other than slope to find a line?
Y-intercept.
Y-intercept or another point. So it's going to be 1 point and a vector that defines the direction of the line. I'm going to put in brackets slope. Okay, I'm going to demonstrate. You probably don't need this demonstrated, but I'm going to do it anyway because I want you to master 2 dimensions so that 3 dimensions becomes easy. What I'm saying is, if I'm given 2 points, okay, what happens is I can make a slope between them, okay, or make a direction vector, that's what they call it in 2 dimensions, and find out the way that's going to be heading. Thank you. Okay. If I'm given a point and a slope, this is going to be my slope. Okay, my point's going to be my finger, that's going to be a line. If the finger's here, then the slope doesn't change, right? That's the way the line's going to go. All right. This works the same way in 3 dimensions, except for that all of a sudden the line is going to be doing this instead of just straight. Okay, but we get the idea. It's either going to be you're making your slope given your 2 points, or you're already given your slope and you use them. Is that logical what I'm doing there? Yes, for most people? Okay, I'm going to leave that there. We'll need that later on. All right. A direction vector. Which we'll be using quite a bit. Is a non-zero vector. Parallel to the given line. Okay, back from grade 9, I notice I use M for direction vector. What does M stand for? Slope. For the French people, it stands for monte. It's to say monte en anglais. To climb. Sloping is climbing, right? So I'm trying. Please stay with me, okay? I'm trying. My daughter's in JK. I'm JK French. Ask her, I guess she is. Here we go. Example 1. so what that should say is a line passing through P 4 comma 3 has M equals negative 7 comma 1 as its direction vector. Sketch this line. Now I know what you're saying. You're saying, Mr. Sadler, this is easy. Did this in grade 9. There's no big deal. I want to make sure we completely understand it in 2 dimensions, because when we go to the 3rd dimension, it's the same properties, it's the same ideas, but it's harder to sketch, it's harder to visualize, it's harder to do all that stuff. So I'm going to take it relatively nicely today. Okay, in English, I'm going to do this on the board, but can somebody tell me in English what I would do to sketch this line? What's the first thing I should probably do? Okay, I'll pick on Spider-Man here today. Victoria. If you're given a point and a slope, what's the first thing that you would probably do to graph this?
If we're given a point on this one?
Yes.
Figure out, like, I don't know, sorry.
No, it's okay. Chris Helper, go ahead.
Wouldn't you like have the point first, and
Yeah.
like regardless whether the point is, the slope is still gonna be the same?
Right, so what I'm going to do is I'm going to graph here. This is just a rough sketch here. Here's my point P, which is 4 comma 3. I guess I don't need to do it that high. Okay. Now for somebody else here. If my slope is negative 7, or if my direction vector is negative 7 comma 1, what does that mean for my next point is going to be? Derek, go ahead.
It's going to be backward 7 in the x, or left 7 in the x coordinate, and up 1.
Okay, can somebody other than Derek please be brave and give me the coordinates of that point? How I would get that? Matt, you want to try? What's the coordinates of that point going to be?
-3, 4.
Good.
Yeah.
Excellent. I'm going to call that Q, okay? Now, just for how we can, I'll connect the dots. I'm going to put, oh goodness. That's supposed to be a straight line. I'm sorry, that's supposed to be a straight line. All right. But the way it's going to go, so everyone see how we got that? Negative 7 in the left direction, right? So negative 7 going to the left and then 1 going up for that. So our starting point was 4 comma 3. Then you went left 7 and up 1. We're okay on the logic of this? It's just a little bit different. Similar to grade 9, but not exactly. It's a little bit different. Did you guys like, by the way, how I knocked the internet out to this classroom today? Did you guys notice that? No, it wasn't me. It wasn't me. I wish it was me, but it wasn't me. No, it's the literacy test, so it's. I've been praying for this.
Don't you dislike English? No.
Let's not talk about that. I don't dislike it. I don't dislike it. Example 2. Here we go. A line passes through A, which is 1/2 of 3, negative 3, right? And B, which is 3/4 and 1/2. Determine a direction vector for this line. Okay, you can sketch it if you want to, but I'm not going to. Okay, if I have points A and points B, the way you're going to do this is we're just going to make a Cartesian vector out of it. So if I say, we're just going to say M is equal to AB. Sorry. Nathan? Yeah. Do you recall how to find vector AB, which you would do?
What was I find?
Vector AB. So I know the points A and B. How would you find the vector connecting them between them?
AX, no, AX plus BX.
Close, minus, okay? So it's going to be for this one, it's going to be BX minus AX and BY minus AY, which in this case is going to be BX is equal to 3/4 minus 1/2 and 1/2 minus -3. So your slope is going to equal 1/4 and 3 1/2.
Do you work with mixed fractions?
7/2 is fine, either one of those is okay. Now here's the deal, guys, the back, stay with me for 1 sec, because this is the key to this lecture. If you are fading out, or dreaming about your birthday party, or if you are saying, I wish this class was over because I want to get to biology to get my biology test back. Nobody's saying that, okay, but let's pretend that you were for a second, okay? This is a slope thing, okay? So my slope here, I'm saying x is 1/4, y is 7/2. You can multiply this. Multiply x and y to get integers for your slope. Okay? So what I'm going to say then is I'm going to say m is also equivalent to 1,14, is that right? Can somebody tell me what I did to get 1 second?
It's a question.
Oh, related to this or?
Yes.
Okay.
This might sound like a stupid question.
No, it will not.
But when you do like a, b, and you do it in the order of bx minus ax and then by minus ay, you couldn't do ax minus bx?
You could, that would be vector BA though. That would be vector BA. But if you were to do that, what would happen was you would have got a direction vector of -1/4 and -7/2, which is still the same thing. Right? That means instead of going like this, you would have gone like this.
Oh, okay.
Which is still the same.
So if I did that, then
Yeah,
I wouldn't.
but you would have to label it as BA though, right,
Okay.
instead of AB. Is everyone okay where I got 1,14 from?
No.
Okay, so what all I did was I just did this. That's all I did. Okay, so that's rid of the denominators. That's what I did. Okay, and think of it this way. If I'm going 1,14, so I'm going 1 across and 14 up. Okay? That's the same as going, well, there's 1/4 and 7.5. It's just that little chunk of it. So I'm doing is I'm just making the line 4 times as long. That's all I'm doing. Okay, but it's still the same slope. It still is the same. Are we all okay, sort of, on what I did there? Right. So instead of using a little small thing, and the same you can divide as well too, and we'll get to one we have to divide. Okay, so you want to get it sort of. All right, here we go. Let's take a pause right now, and then we'll move on here in a second. Okay. You like pauses.